So if we look again at the Rydberg's equation, and given our discussion of the Bohr model, we can then start to think about, well, how do we get these particular wavelengths of light either from the absorption or the emission spectrum of the hydrogen atom. And so this model does a pretty good job of predicting that. So for instance, if we say we can predict, for instance, if we have an absorbance that allows an electron to be excited from the n equals 1 orbit or n equals 1 state to the n equals 2 orbit, where we excite the electron to that electron configuration, we can then say, all right, n equals 1 is the lower quantum number. We're going to replace n1, which would be the lower of the two states that we're trying to calculate between. And then n2 would be the higher principal quantum number, would be 2 squared, okay? And then if we're doing the hydrogen atom, then Z, right, this is going to be the nuclear charge, right? So Z would be 1 squared. And then we have R of 1.097 times 10 to the 7th per meter. We could calculate this where we'd have 1 over 1 minus 1 over 4. That'd be 3/4 times R would be equal to 1 over lambda, where lambda would be the wavelength of the light, where we would either expect there to be a gap in the absorbance spectrum, or we would expect to see a band indicating emission of a wavelength of light of lambda, okay? And so this Bohr model does a really good job of explaining the Rydberg equation. There's, however, it's not the weakness of the Bohr model is that it only applies to hydrogenic atoms, okay? So if we reset this equation here, what we mean here by that is that hydrogenic atom is a species that only has 1 electron, okay? All right, so that includes, again, for instance, the hydrogen atom, or the helium plus 1 ion, or the lithium plus 2 ion, etc. Okay, so again, this only applies to systems that have 1 electron, and then as we increase, and we can increase the, we can change the atom we're looking at, and when we do that, we would change the value of Z depending on what the nuclear charge is. So for instance, hydrogen would have a nuclear charge of 1, helium would be 2, lithium would be 3, so on and so forth, all right? But again, this model and the Rydberg equation only applies for these hydrogenic atoms, okay? So this is a limitation of the Bohr model. And so we have to find another way to explain for more complicated atoms that, for instance, if we're talking about the helium atom, which now has 2 electrons, 2 protons, and 2 electrons, right? So that would not qualify as a hydrogenic atom. And so how can we start to explain more complex systems such as the helium atom?